right, we're going to be doing absolute value graphs. And we're going to do this with two variables with an x and y. And this is section 2.8. Let's get started. We're going to discover relationships with your graphing calculator, and you received a worksheet that told you how to do that. And we are going to use some new buttons here. There's a y equal button that's right here, and you're going to click that. When you get into that menu, you're going to have some y1 and y2 and y3s and equals. And right there, you can just plug the equations right in. If we were going to plug an equation of a line, we might say 2x plus 4. And once we get it in there, we push the graph button, and it should just graph it automatically for you. Now, we're going to be graphing some absolute value graphs. So to be able to do that, you need to know where on your calculator that is. So you need to be able to find that absolute value. So it's right here. It's inside your math menu. That's really the same place where your fraction button is. It's just that when you get inside there, it's right in there. And when you get in there, you're going to actually hit your side arrow here to scoot over, because there's going to be a menu at the top that says num in there. You're going to pick it. Then you're going to just pick that absolute value. Depending on the age of your calculator, it might have the word abs there, and you'll put an X in, and you're going to find that X right here, on your calculator. Okay? Some of you will actually have the lines in there for you to use it. So depending on the age of your calculator. So go ahead and work through that worksheet. Come on back and let's recap what you did. Pause the video and come back when you're ready. All right, on that graph, you put in these two equations. You put in y equals absolute value of x and y equals x plus 2. I want you to notice that whenever you do an absolute value graph, nothing goes into the negatives. Everything stays positive here, and then it pops it back up into the positive again. Now, but if I add a 2 to the outside of this equation, what does it do to this graph? I want you to notice that it moves it up 2 spots. You might have put something, hopefully on the worksheet, you put something like moved up by 2. Okay. Now, another absolute value equation that I'm going to put in, it's a little different than your worksheet, but it has this similar effect, is that if I didn't put something on the outside, I put it on the inside. And when I put a 3 on the inside, right in here, did it move it? Yes, it did. And I subtracted 3, but I want you to notice something. It moved it 1, 2, 3 to the right, or towards the positives. If I added on the outside, it moved it up. But if I subtract on the inside, it moves it to the side. Something that hopefully you would have noticed when you did this, if I would have done a y equals absolute value of x plus 3, it would have moved it over this direction and then had my absolute value graph after that. So when you put things on the inside, it actually does the opposite it goes in the opposite direction, left or right. But on the outside, it moves it in the direction you would most logically assume. All right, now let's do one more scenario here. So I have that reference graph, but what happens if I put a negative in the front? What does it do to that graph? I want you to notice here that our original was upright, and now we put a negative in front and it turns it upside down. So whenever you put a negative in, it turns it upside down. All right, let's talk about this. Let's talk about this vocabulary word that's up here at the top. It's called the vertex. The vertex is the dot that's where that point comes together right there. And I want you to notice that I went over 5 this way and 3 this way. I went over 5 this way and up 3 this way. So the vertex is at 5, 3. Now, if we have an equation here, and if I wanted to do two things, I didn't want to just move it to the left or the right, I wanted to move it both, I would put numbers in both of those. And if you remember, this one moved it in the direction that was most logical. So for my equation on this one, I should have a 3 right there. So I should have y equals x minus something plus 3. Now we moved it in the positive direction, but those were opposite, so I'm going to have a minus 5 in there. So my vertex for this one is 5, 3. What will the vertex for this one right here be? Number 1. This is number 1 from your homework, so you might want to get that out. My vertex is going to be 4, and it doesn't move it anywhere. It's like plus 0 right there. 4, 0. That means I moved it to the right 4. The cool thing about all of these is since there's an invisible 1 in front right there, the slopes of both of those are 1 and -1 because we go up here and there. Let's do the other one right next door. What did this do to this? Did it move it up, down, left, or right? Well, it moved it down. It started here, and it moved it down 4. 1, 2, 3, 4. And my slope is still got an invisible 1 right there, so it goes up 1 this way, and up the 1's over here. We're going to do those corners, up 1 over 1. There we go. Let's move on to the next one. All right, let's do number 5 and 6. I actually like to write the vertex, what it will be. Remember, it's the opposite of this one and the same as that one. So my vertex is going to be 1, -2. So I'm going to be at 1, -2. And I'm going to go up 1 and over 1 on all sides. Up 1 and over 1, even backwards here. And then I need to draw my arrows. There we go. Let's do the next one. This one has a vertex. We take the opposite of that, so it's 2. And we take the same as that, which is 1. So 2, 1's right there. And we're going to come up 1 and over 1. We always come up 1 and over 1 as long as the number in front right there is an invisible 1. All right, let's do some more. All right, let's do number 9 and number 11. This time I want you to notice that we have this negative in front right here for the 9. And so my vertex is the same as how we find it the same way we've been doing. We take the opposite of that, this right here, which is 4, and we take the same as that, which is -1. I'm going to plot my 4, -1, which is right there. But because of that negative, we're not going to come up this way. We're going to go upside down. So we're going to come down here, 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 down. So we have a negative slope for those, or an upside down. All right. This one, though, over here on 11, it doesn't have anything out here. So my vertex is 3, 0. And I've got here, but I don't have a 1 in front. I have a 3 in front. That means my slope is 3. I'm going to come up 1, up 3, and over 1 on both sides Notice that my graph is thinner now. It's not as wide as it was before. All right, let's review what we've done. We have graphed absolute value equations. The standard form of that equation looks like this. And we have a vertex is HK. We take the same as this one right here. Excuse me, the opposite of that one right there and the same of that one. And the slopes of the lines is the same as the number in front of that absolute value. And a negative makes it go upside down. I hope this has been helpful. Goodbye.